Hello, in this video I am going to explain elastic properties of materials which comes under volume 2 of video syllabus. So here I am going to discuss about relation between elastic constants. Now I am going to take up a topic that is relation between elastic constants and sigma, relation between shearing strain, elongation strain and compression strain. And here is a diagram. So here is an object, okay, it is cubic in shape, and the lower end, that is ds, is fixed, and the upper end is subjected to a force acting along x direction. So because of the applied force, the point A is shifted from A to A dash, and similarly the point P is shifted from P to P dash, and because of this there will be a angle of shear, that is theta, is coming to picture, that is theta is equal to x by L as per the picture. Here L is the length of the cube as shown in the picture. Now let us consider a cube whose lower surface is fixed to a rigid support. Let APSD be one of its faces with the side ds along the fixed support. When a deforming force is applied to its upper face along AP, it causes relative displacements at different parts of the cube, so that the point A moves from A to A dash and P to P dash. Let theta be the shearing angle. Also, one can notice that the diagonal AS of the cube is now shrunk to A dash S, and PD is stretched to a length P dash D. If PX is drawn perpendicular to P dash D and A dash Y to AS, then DP is equal to DX and A dash S is equal to YS. Therefore, elongation strain is equal to P dash X by PD. So consider that as equation number 1, and the compression strain is equal to AY by AS, that is taken as equation number 2, and if L is the length of each side of the cube, then AS is equal to PD, that is equal to root 2 L, that is as according to Pythagoras theorem. So consider this as equation number 3. But P dash X is equal to PP dash cos, that is PP dash X angle, and P dash X is equal to PP dash cos 45 degree, that is equal to PP dash divided by root 2. So consider that as equation number 4. Substitute the value of 3 and 4 in equation number 1, then it can be written as elongation strain is equal to PP dash divided by root 2 divided by root 2L, so that is equal to PP dash by 2L. But PP dash is equal to theta into L, therefore the elongation strain will be equal to theta by 2. Consider that as equation number 5. Similarly, compression strain along AS will be equal to theta by 2. Take that as equation number 6. Therefore, elongation strain plus compression strain is equal to theta by 2 plus theta by 2, that is equal to theta, that is the shearing strain. If alpha and beta are the longitudinal and lateral strain coefficients produced along dP per unit stress capital T, then along dP, tensile stress will be equal to T into dP into alpha. Therefore, the compression stress is equal to T into dP into beta. Therefore, the total extension along dP is equal to dP into T into alpha plus beta. So finally, P dash X is equal to root 2 L T into alpha plus beta. Similarly, from equation number 4, P dash X is equal to X by root 2, that we can write. So finally, root 2 L into T into alpha plus beta is equal to X by root 2. Rearranging the above equation, we can write 2 into alpha plus beta is equal to X by T into L. So finally, we are going to arrive at an expression for N is equal to 1 by 2 into alpha plus beta, that is equal to 1 by 2 alpha into 1 plus beta by alpha. So this is the expression for the rigidity modulus, that is N. So finally, we are going to get y is equal to 1 by alpha. So we can write N is equal to y by 2 into 1 plus sigma, and finally the value of y is equal to 2n into 1 plus sigma. That is the final expression. Now let us discuss about relation between k, y and sigma. So consider a cube of unit length, breadth and height. Let Tx, Ty and Tz be the outward stresses acting along x, y and z directions as shown in figure. Let alpha be the elongation per unit length per unit stress along the direction of forces, and beta be the contraction per unit length per unit stress in a direction perpendicular to the respective forces. Then a stress like Tx produces increase in length of alpha Tx in x direction. Since Ty and Tz are perpendicular to x, that is x direction, they produce contraction beta Ty and beta Tz respectively in the cube along x direction. Hence a length which was unity along x direction now becomes 1 plus alpha Tx minus beta Ty minus beta Tz. Similarly, along y and z directions, the respective lengths become 1 plus alpha into Ty minus beta Tz minus beta Tx and 1 plus alpha Tz minus beta Tx minus beta Ty. Hence, the new volume of the cube is as according to the expression below. Since alpha and beta are very small, the terms which contain either powers of alpha and beta or their products can be neglected. New volume of the cube can be written as 1 plus alpha minus 2 beta into Tx plus Ty plus Tz as according to the simplification what we obtained. If Tx is equal to Ty, that is equal to Tz, that is equal to T, then the new volume can be written as 1 plus alpha minus 2 beta into 3T. So finally it will be equal to 3T into alpha minus 2 beta. If instead of outward stress T, a pressure P is applied, the decrease in volume is equal to 3P into alpha minus 2 beta. So finally the value of K is equal to pressure by volume strain, and the value of K will be reduced to Y by 3 into 1 minus 2 into sigma as per the expression shown. Now let us discuss about relation between K, N and Y. We know that Y is equal to 2N into 1 plus sigma and K is equal to Y by 3 into 1 minus 2 sigma, and hence we can write Y is equal to 3K into 1 minus 2 sigma. But it is observed that Y by N is equal to 2 into, that is 2 plus 2 sigma. So Y by 3K is equal to 1 minus 2 sigma. So finally we can write Y by N plus Y by 3K is equal to 3. So finally we can write Y is equal to 9NK by 3K plus N. So this is the way of obtaining expression for Y in terms of N and K. So relation between Kn and sigma. So here we are having Y is equal to 2N into 1 plus sigma and Y is equal to 3K into 1 minus 2 sigma. So finally after simplification we are going to get sigma is equal to 3K minus 2N divided by 2N plus 6K.